What is going on, everybody? Welcome to part 16 of our data visualization with Matplotlib and Python tutorial series. In this video, we're going to be talking about live graphs with Python. So if you're following along linearly, this is the code that we've left off on. We're going to go ahead and delete it, but if you're following along and you're going to continue along in the series, I suggest you save this code somewhere. Otherwise, you can go ahead and head to pythonprogramming.net and re-get the code. So anyway, I'm going to delete this code, and now what we're going to do is just purely post code or write code here that's applicable to this specific video. So first of all, we want to import matplotlib.pyplot as plt. That doesn't change. We've been doing that this whole time, and really that'll never change. Then what we want to go ahead and do is we're going to bring in the animation functionality. So import matplotlib.animation as animation. Then we're going to bring in one more thing, and that would be from matplotlib import style. So we've kind of covered styles already. We just use it to quickly make our graph look a little more appealing than it does naturally. So first we'll do style.use, and we're going to say style.use. We'll do that 538. That seems to be my favorite one. Next, what we're going to do is we're going to say fig equals plt.figure, and then we'll add an axis. Whoops, we'll fix this figure. Then we're going to add an axis, so we'll say ax1 equals fig.add underscore subplot, and then we'll do a 1 by 1 by 1. So add subplot, I don't think we've really covered much of this. We did subplot to grid before. Neither of these we've really talked about in depth, so really don't worry about it, but this just means it's a subplot that's on basically a grid sort of system that's a 1 by 1, and this is plot number 1. But we'll talk more about those later on. Now, what we're going to do is we're going to say define animate, and then we'll pass one parameter will be I, and that'll be the interval. And then now what we're going to say is we're going to call graph underscore data, and we're going to say graph data is equal to open, and then we're going to create a sample file. It doesn't exist yet, but we'll just say sample file.txt with the intention to read, and then we'll go ahead and read it. Now again, we don't have that file yet, so let's go ahead and create it now. So this is where I'm coding all this. This is the actual script that we're writing right now. So just down here, or actually we already have an example file from the previous tutorials, so we'll just use this one actually. So double click on that just to bring it up. Basically it's just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then for those are the x's, then we've got some random y's. It really doesn't matter. You can put in whatever coordinates you really want. These are just the ones I'm going to work with. So I'm going to leave this file up. I'm just going to put it over here for now. So this was example.txt. So let's just change this to example.txt. Save that. So now we have the file. And then now what we're going to go ahead and do is we'll say lines equals graph underscore data dot split. And we're going to split this by the new line. Okay, so \n is the new line. Then what we're going to do is we're going to have the x's equals to an empty list and the y's equal to an empty list. And then what we're going to say is for line in lines, what do we want to do? Well, we're going to say if len of line is greater than 1. So sometimes you might have like a line, like an empty line at the end of your files. So I always like to handle for this to just check to make sure that line is not totally empty. It's a really common thing people ask like, you know, how do I trim away that empty line and stuff? Well, you can just use some handling. You can trim away that empty line with some code, or you can just handle for, hey, if that line is empty, ignore it. And this is usually less logic required. So anyway, so if the length of the line is greater than 1, we're going to say x comma y is equal to line dot split, and we split by a comma because our delimiter here in our file was commas. So we'll split by a comma, and then we're going to say x's dot append x, y's dot append y, and really that's it. So then what we're going to do is we'll get out of this for loop, and then now what we want to do is we want to modify our axes. So first of all, to plot, we already know how to plot. We could do ax1.plot, and we plot the x's and the y's. And that's all we have to do in our animation function in theory. But the problem is, if basically this animation function is just going to keep running, and it'll keep updating our figure, and every time we draw something to the screen, there's nothing to get rid of that something that we've drawn previously. So we also want to call an ax1.clear before we plot the new data, so that'll wipe the slate clean and then redraw, including new data, if there is new data or not. It's a relatively computationally light. Really, the heavy computation is the actual drawing of anything and then the rendering of those things. So clearing everything out really doesn't cost us anything. I mean, it costs a little bit, but nothing much. So like some people kind of consider that like you're like wasting or something, like you're clearing away and then you're drawing like 99% of what you had before. But it really doesn't cost you much. It's the rendering that costs you the most, and having many lines costs you a lot. So anyway, clear. So that's our animation kind of function here. Now what we're going to do is come outside of this function that we've been writing, and now we'll just do ani, or ani for animate, and we're going to say that is equal to animation, which is in reference to this right here that we've imported, equals, so animation dot capital F func animation. So this is a method that allows us to animate based on a function. If you can guess, we're going to animate based on this function here. So func animation, and then the question is, where are we going to animate this function to? Well, figure, we've defined that up here. Then, what is the function that we're going to animate? That's animate. And then finally, any parameters that you're going to pass and stuff, we would do that. And we're just going to say interval equals 1,000. This is in milliseconds. So 1,000 milliseconds is 1 second. So every 1 second, this graph will update. Along those same lines, in order to, this will update in the background, but we don't have a plt.show, so we need to call that now. So plt.show, and that's it. So now we'll save and run this, and up pops our current graph. It is updating, whether or not you know it. And we'll come over here. Let's put the graph like right here. And then this is the sample file that we've been working on. So I'm just going to add, I don't know, 11.5. So 11,5, Control S to save. And there you have it. Our graph is updated. And I mean, we can keep going like 12, 11 if we want. So you can see it just keeps updating, 13, 7, okay, and so on. So you can use this to really have updating graphs anywhere, right? Like it just so happens that we're pulling from a static text file that only gets updates from us. But as I've already shown you guys, we can pull information for stocks offline, for an example there. And so you could have graphs pulling from some sort of stock price API, and the graph is actually updating live on your screen. So that's pretty useful. And also another useful aspect people use live graphs for is like sensors. So people will use Matplotlib to display data from a sensor, but a lot of times that sensor data is really live and it's coming in constantly. So they would use this animation function so they don't have to keep like loading their graph over and over or something like that. Anyway, that's it for this tutorial. If you have any questions or comments up to this point, please feel free to leave them below. Otherwise, as always, thanks for watching. Thanks for all the support and subscriptions. And until next time.